On yesterday, we looked at how to rewrite between an exponential and a logarithmic equation and did some basic evaluating with regards to that equation. So remember the basic setups for an exponential and a logarithmic. The exponential equation is b to the x power equals y. So when we put it in logarithmic form, we're still using the same base, the same x, the same y. We're just rewriting it in a different format. Log, lowercase b, y equals x. So the b to x and y are the same. Let's see, you can't see it. All right, just a second. Turn the record back on. So yesterday, we looked at how to convert back and forth between the two and do some basic evaluating with the actual expressions. So today, we're going to actually solve equations with them. So for a logarithmic equation, to start out, there are two different ways to solve the equation. One of them is when you have logs on both sides, and the other is by doing a rewrite. So these are the two simple cases for a logarithmic equation. So there are other cases that go a little bit deeper. In order to go deeper into a logarithmic equation, there are certain properties that you need, which you will pick up on Thursday. So on Thursday, we'll do the properties, which will lead us to being able to solve deeper equations going into next week. So today we're going to deal with the two basic types. So, first basic type is if you have logs on both sides. So if you have logarithms on both sides, there's a specific property that allows us to do our work. So think back to an exponential equation. If you had 3 to the x plus 2 equals 3 to the 2x minus 1, since the bases were the same, you were able to drop them out and work with what was left over. That was the main aspect of section 7.2. The same exact thing works for a logarithm. If your log has the same base, then you can cancel them out and work with whatever's left over. But that is only if the logarithm has the same base. So on your notes handout, both of the bases were 5s. So that allows you to cancel them out. So if one of them was a 5 and one of them was a 2, then you can't do it. That's not solvable. But if they're both 5s, drop them out, solve what's left over. So with that, we're going to work 3 examples of a logarithmic equation in this type. So example 1, of course, if I'm going too fast, either at home in here, just stop me so I can slow up a little bit. The log x plus 5 equals log 3x minus 5. So remember, this log doesn't have a little base. So remember that understood base is 10. So it's not required that you go ahead, that you put that base there. I'm doing it more so to remind you to do it. And whatnot. But both of the bases are 10s. So since both of the bases are 10s, we're going to drop them out. No, you with? Okay. So they both have the same base. Those drop out. So that means you're left with x plus 5 equals 3x minus 5. That ends up being a relatively easy equation to work itself out. Subtract your x, add your 5, and then divide. Any questions so far? Everyone in here good? So, exponential equations, the answers do not have to be checked. Logarithmic equations, they do. So these answers do have to be checked. So when you take the number and plug it in, both of those values should match. So both of those values should match if you do it correctly. That's one thing. The other thing, which is very, very important, neither one of these can be negative. Neither one of those, when you finish it off, can be negative. So if that happens, that answer doesn't work.
And is that with like every problem that it can be negative?
That's for every logarithm. So the part that comes after the log cannot be negative. But it can't be negative. If it pops off negative, it's not valid. So okay, so again, you do not have to show that it doesn't work unless you don't have to show the work for that unless the answer doesn't work.
And they have to be the same number.
They have to be the same number. So we plug in the 5, 5 plus 5 is 10, 3 times 5 is 15, minus 5 is 10, everything checks out, we're fine. So example 1, we're good to go. So, any questions? Example number 1. All right. Same rule applies. Let's do example 2. So log base 4 x squared equals log base 4 negative 6x minus 8. So as you can see right off the bat, the bases are the same. You can get rid of them. So notice we've got x squared in the problem. So that means this is either going to be factoring, square roots, quadratic formula. Ideally, we want to factor and take the square root before we have to use quadratic formula. So when we take negative 6x and the negative 8, move it over. So added 8 to both sides, and then added 6x to both sides. That's where our new equation came from. Any questions either here in class or at home before we continue? Jake, you all good? All right, so let's go ahead and keep it moving. So This is factorable, right? You can factor this?
It's 4 and 2.
4 and 2 this thing. X plus 4, x plus 2. So x equals -4. X equals -2. And of course, the only thing we have to do is check it.
Isn't it a difference between them?
You have to plug in both of them. So -4, check to make sure it works, then -2, check to make sure. I mean, one can work and one can fail. So each one is on its own. So they could both work. The -4 could fail, or the -2 could fail. Or both of them could fail. So if both of them fails, it's no solution. So again, we check each of the answers just to make sure that they work out. -4 squared is positive 16. -6 times -4 is 24. 24 minus 8, positive 16. So -4 we know is valid. -2. -2 squared is 4. -6 times -2 is 12. 12 minus 8 is 4. That one's also valid. So both of them checked out. So just a reminder, both for those of you at home, those of you in here, I don't need to see the work for you checking it unless the answer doesn't work. If it doesn't work, then I want to see the work that shows why it didn't work. Otherwise, you don't have to show that work. Now, if you want to show it for your own peace of mind, then do you. I trust y'all. Any questions before we do the last one? All right, so example 3. It starts out looking pretty harmless. Base 3's, pop out. X squared minus 15 equals 2x. So again, you've got x squared in the problem. So that means we need to get this equation equal to 0. So get the equation equal to 0. Let's see if this is factorable.
-5.
So -5 and a positive 3. Yeah, that works. So x equals 5 and x equals -3. We all agree so far? All right, so right now, this is where we're at. Now we have to check it to make sure that they work out. So we start with the 5. 5 squared, 25. 25 minus 15 is 10. 2 times 5, 10. So 5 we know works out. -3. So -3 squared is 9. 9 minus 15 is -6. Uh-oh, we got a problem. So when you do log base 3 of -3 squared minus 15, that's 9 minus 15, -6. You cannot take the logarithm of a negative number. You can't take the log of a negative number, so -3 is not valid. take the log of the negative number. So I want to at least make sure you saw one example of where something's not going to work. Other than that, not a hard problem. If the bases are the same, cancel them out, solve everything that's left. Any questions before we continue? Love having people in class. And therapy for my soul. All right. No questions in here. Any questions at home before we do type number 2?
Chat real quick. All right. Hey Nick, if you can hear me, when class ends, just hang back for a second. I'll talk to you about something. I don't know if you can hear me. Just when class ends, just hang back for a moment.
All right. So the other type is when there's one log in the problem. So one log, we rewrite. We do the rewrite. So that's when you are going to start log base b y equals x. You're going to start with something in this format. You're going to change it back to an exponential equation and solve it from there. So you're going to change it back. You're going to change it back to an exponential equation and then solve the problem from there. So let's launch right into it with example number 1. So example 1, you have log base 4, 5x plus 1 equals 2. So your 4 is your base. 5x plus 1 represents the y component. So you take all of it together. 2 is your x. Let's see your finish. You should have 3. So when we do the rewrite, b is 4, x is 2. So 4 squared equals 5x plus 1. So that's what you should have if you rewrote it correctly. That's a pretty simple equation to work out. So 5x plus 1. Subtract the 1. Divide by 5. So x equals 3, done. So again, same rules apply. So this 3 can't make the y negative, and the base can't be negative. So the base can't be negative, the y can't be negative. The x can do whatever it wants. X can be whatever number it wants. It's the base and the y component that can't be negative. That can't pop off as negative. So if you put 3 in there, 5 times 3, 15, plus 1, 16, we're good. So when it's in logarithmic form, the b component and the y component cannot be negative. X can do whatever it wants. Any questions with example number 1? Try my best to keep it as simple as possible. Or still got time. We all good? Yeah. All right. All right, so example 2. So example 2 works the same way. 16 is your base. The x is where the y component is. 5/2 is where the x component is. So if we do the rewrite, that ends up being 16 to the 5/2 power equals x. So this actually ends up being something that we can just throw into the calculator and get it taken care of. So, sounds like a good opportunity to break out our calculator. That and make sure that those people who have the calculator, that we get it in the right way. All right, so let's clear all that out. All right, so the problem was 16 to the 5/2 power. So type in our 16. Use the exponent key that's right above the division sign. And then, so if you have a newer style calculator, it's going to make it an exponent automatically. So you can put in 5/2, and then it'll give you your answer. If you have the older model calculator, then after you use the exponent key, make sure you put your exponent in parentheses. Either way it goes, you should get the same answer, which is 1024. So if you've got a fraction as an exponent, don't be afraid to go ahead and throw that back on the calculator, get it taken care of. So x equals 1024. Any questions, example 1 or 2? So far, so good. All right. Now let's keep it right on moving. So example 3, log base x, 32 equals 5. So again, same rules apply. The x is now where the base would be located. 32 is the y. 5 is the x component. X to the 5th equals 32. So x to the 5th equals 32. So to solve it out, we're going to be doing the 5th root. So in this case, most people will probably opt to just doing the trial and error, what to the 5th power is going to give us 32, which is 2. So this number is not that difficult to get. However, if we were going to use our calculator to solve this out, so the 5th root, first you type in the number 5, go to math. The 5th button down is for any roots that are higher than 3. Fifth root, 32. Get your answer of 2. So if it's a simple enough number, go ahead and just work it out yourself. But for more complex numbers, then go ahead and use calculator. So, any questions 1, 2, or 3? All right. So let's look at number 4 before we tackle the word problem example. So this time with example 4, you have a lot of stuff around it. You have a lot of stuff sitting around the logarithm. So we cannot do a rewrite until that log is completely by itself. That means this 13 has to go, and that 4 has to go before we do any kind of rewriting. So 13 and the 4 has to go. So 13, we will subtract it. So 24 equals 4 log base 6 of x. That 4 is multiplying times this log, so we're going to divide it to get rid of it. Log base 6 of x. So let's pause for one moment. Give some folks a moment to catch up. Any questions so far? So far, hopefully pretty easy peasy. Now that the log is by itself, now we can do the rewrite. Now we can go ahead and do a rewrite. 6 is the base. The x is where the y should be. The 6 is where it's in the x position. So 6 to the 6th power equals x. So there's going to be some big, gargantuan, ridiculous looking, fantastic number. 46,656. So again, don't be surprised if you get numbers that are really, really huge. That doesn't mean you did the problem wrong. Logarithms and exponential functions do tend to get numbers that are going to be pretty huge, and conversely, pretty small, depending on what you're working. So if it happens, that's not an indicator that you did something. So, any questions, either at home or in here? Any questions?
No.
Yeah. Go ahead.
Okay, so, but the way I thought about it is this.
Mhm.
So I think the basic like 6 equals that's what I got. But then you put 6 to the power of something.
So remember how it's what the general formula is. So the general form is log base b. The next part that comes after it is the y component. So this part is backwards, but if you turn it around, you would have log base 6 x and 6.
Is like, how that attach to the line?
Which part, the x? So the base is always that lower number. The next thing that comes after the base is the part that you're taking the log of. So this part should sit a little bit higher than the base.
So it's not like exponential.
So no, it's not an exponential. And it's probably looks that way based off of the way that I wrote it, so that's more on me than anything else. But this isn't 6 to the x power. This is log base 6 of x. So I see where you're coming from. Good question there. Any other questions before we word problems in. All right, so this type of problem will actually help with a couple of the problems that are on the homework that is due tomorrow, as well as reinforce the concept that we're doing now. So this is definitely for my potential engineers. The equation for wind speed near the center of a tornado is given by that equation right there. V is the distance in miles that the tornado travels. So luckily, thank God, I've never had to deal with a tornado. Don't want to deal with a tornado, don't have time for all this. I have dealt with a hurricane. I've been inside of a hurricane. Don't want to deal with that for you. But so the longest tornado in terms of distance traveled in recorded history traveled 218 miles. Find the wind speed near the center of that tornado. So imagine a tornado going 218 miles. So it's going to pretty much rip up everything from Chicago down to just about past Peoria, maybe down to Springfield. So imagine that kind of distance. So travel 218 miles, find the wind speed near the center. So we don't know what W is. They gave us what D was equal to. So this is more so just a plug and chug problem. This is pretty much a plug and chug problem. So 93 log base 10 of 218 plus 65. Now, here's one mistake that a lot of people make with this problem. Do not take 218 and add it to 65. 218 is attached to that. 218 is attached to the log. So do not take 218 and add 65 to it. So there's a mistake that a lot of people make. So when we solve this, we're about to let the calculator do it. So when we put this in the calculator, we're going to have 93 log. So the calculator is going to open up the parentheses. That's where the 218 goes. After we type in the 218, we're going to close the parentheses. That way the 65 stays out. So when we put in the calculator, that 218 is the only number going in the parentheses. Everyone clear and straight with that before we do it in the calculator? There's no calculator there. Left it at home. Let's see. So let's go ahead and throw this in the calculator. 93. Remember, log is next to the number 7 and below x squared. 218 plus 65. If you're wondering, what about the 10? The calculator is already in base 10. So you do not ever have to tell it base 10. It knows it already. So there's your wind speed. So this tornado is about 282.5 miles per hour. Wind speed 282.5 miles per hour. The tornado is faster than a hurricane. It's this one. Any questions on part A? So another 2 problems on the homework that's due tomorrow. That it's basically plug and chug problems are problems 50 and 57. So this is how you would handle a plug and chug problem. So now let's turn it around. A tornado with a wind speed of 275 miles per hour is characterized as an F5 tornado, the highest rating of destruction a tornado can have. Find the distance that this tornado would have traveled. So, 275 mile per hour tornado. F5 is just telling you what kind of tornado it is. That has nothing to do with the solving of the problem. So we're still using the same formula. Log base 10 d equals 3 plus 65. But this time, now we know the wind speed, we don't know the distance. So now we know the wind speed. This is our setup so far. Any questions, comments, concerns before we move on? Give some people a moment. See some people still writing. That's right. So, part B is very similar to what we did with example 4. We've got to get the log by itself first before we can solve or do the rewrite. That means the 65 has to move and the 93 has to move. I'll let y'all take a moment to take care of that. 65's got to move and that 93's got to move before we can do the rewrite. So, take care of that real fast. You're welcome. Same rules apply, Noah. Closed mouths don't get fed. Alright, so if we are working this out correctly, so we should have 210 equals 93 log base 10 b. 210 divided by 93 is going to give you a decimal, so you got freaked out. Don't. 2.258 equals log base 10 of b. Where we at? We all good so far? Anyone not get to this part? So now that we have gotten to that part, we can do the rewrite. Once log is by itself, we can do the rewrite. So there's our d component. So remember, people, this isn't 10 to the d power. 10 is the base. D is the component for the y. And that's your x component. So our rewrite is 10 to the 2.258 power equals, well, use the variable that's over here, d. So then that becomes the calculator part. So this tornado traveled 181.1 miles. So if you're comparing the two, the faster, you could say that the faster a tornado is going, the farther it's going to travel. But every tornado is different. Yes, hopefully you never ever have to experience one.
Where's the next
Hurricane was down in Florida. I went to Disney World for the one and only time in my life. And while I was there,
Are you from?
born and raised, I went down to Florida for spring break my sophomore year. Probably the only time I'll go to Disney World, primarily because I didn't have to pay for it. If I had to pay for it, probably not gonna. Really fun, really expensive, but really fun. Oh, man, it's you, of course you want it. Any questions? Example 5. Let's see. Looks like everyone in here is good. Any questions at home with example 5? Any questions on any of the 8 examples? Any of the 8 examples? Anything that didn't click? Anything that might be a little weirded out about?